In this video, what we're going to do is flatten the base curve of the lens by a diopter and then decrease the sag of the lens here at the edge control point by 12 microns. So we can see the base curve is 8.67 right now with a corresponding power of 0.31 diopters. And when we're looking to flatten the base curve by a certain amount or steepen the base curve by a certain amount of diopters, it's nice to just look at the power. If you're a seasoned contact lens practitioner or you do math really quickly in your head, then you can look at the base curve. But I like to use the power because what Wave does is as you flatten the base curve or steepen the base curve, the Wave software will adjust the power accordingly. So if we flatten the base curve, the ending lens will have a power of 1.31 because Wave knows if we flatten the base curve by a diopter, we're going to need about a diopter more plus in the lens power so that we have the equivalent refraction. So I'm going to set this to 4x just so it goes a little bit faster. And we're going to click up. And you can see the power increasing and the base curve radius in millimeters increasing as well. Okay, overshot a little bit, so we'll back off. Back to 1x and just fine tune this. Okay, so that's pretty close. So one recommendation I have is anytime we change the base curve, especially in freeform mode, what we want to do is go through the different meridians and make sure our power is close to 1.31 in every meridian. Even though we're in 100% mode, the power does not always change uniformly in every meridian. So for example, here in this 230 meridian, we can see power is actually 1.5 instead of closer to 1.31. So we're going to go into 25% mode. And we're just going to decrease this a little bit. Yeah, that's pretty close to 131. Again, we're a little bit over, so we're going to steepen the base curve a little bit. And then do that for each meridian. I'm going to go ahead and make that change, but I'll pause the video in the meantime because you don't really need to see me doing that. Okay, so I went through all the meridians. Some were a little bit flat, some were a little bit steep, but all of them are pretty close to 1.31, and just made some mild changes, and they're pretty uniform all the way around now. So the base curve is set. The next thing we want to do is decrease sagittal depth at this control point, the edge control point, by 12 microns. So down here we have a sagittal depth value, and 1870 is the total sagittal depth of the lens in this particular meridian. So that's good to know, but if we want to make a specific sagittal depth change, then what we want to do is right click on the graph here, and we can see at the pink or edge control point, we're at 1,619 microns deep. And this is a figure we want to use if we're changing sag depth at a specific value. Sometimes we'll want to change the sag specifically at the IC or the blue control point. And the red control point controls base curve. Usually for that, we're not looking at sag so much. We're actually looking at the power or the base curve. But when we're making sagittal depth changes either at the back of the reverse curve or at the alignment curve, we want to use these values as opposed to the total value, because the total lens sag does change as we change these values, but going by these numbers gives us a little bit more precision and better control over what we're changing. So for example, in this case, if we want to decrease sag by 12 microns at the pink control point, right now we're at 1619, our target will be 1607. So let's go back to 100% mode because we're going to make this change all the way around the lens. 3 clicks at 4 times, and we're at 1607 exactly, so perfect. We are where exactly we want to be. Um, Sagittal depth changes around the periphery or at the blue dot tend to be a little bit more uniform when it comes to the software calculations, so I usually will not go through each meridian to double check each value. Well, the base curve I will, because that tends to be a little bit less uniform. We do want to make sure we don't end up with a toric base curve unless that's what we really want. But in this case, if we were looking for a 12 micron decrease, then 1619 to 1607 is a 12 micron decrease, and we are set. This lens is ready to be ordered.